Hey everyone, welcome back to the channel. Today we are diving into a fascinating problem, palindrome. This is LeetCode problem number 9. It's called palindrome number. So the problem says given an integer x, return true if x is a palindrome or else return false. So what is palindrome? Palindrome is something which reads the same forward and backward. So for this problem we are essentially checking if number reads the same backward as forward. Basically, we are dealing with integer palindrome. I would start by handling a quick base case. If the number is negative, it's not a palindrome. How to check that? If x is less than 0, return false. Also, we need to handle one more base case here. If the number ends with 0, then it can't be palindrome. And how to do that? We take x modulo 10 to get the last digit of any number, and if it is 0, then we know that it's not a palindrome, because if we take say number 100 and read it backwards, it would be 001, which is not a palindrome. This holds true for all numbers which end with 0 except single digit 0. So we need to make sure if a single digit 0 is passed as the input number, it's not returning false, it should return true. Okay, so this is done. First I will start with approach, where I will convert the integer to a string, and I'm thinking of using two pointers, one starting at the beginning and the other at the end of a string. They will move towards each other comparing characters. If at any point they don't match, then it's not a palindrome. If they make it all the way through, we have a palindrome. Let me start coding this part. This approach is called as two-pointer approach. So first we convert. Let me give this a name, approach 1, using pointer. So here we first convert the integer to string. Let's say strx, use integer to string to convert the number to string. Now here we will initialize two pointers, left and right. Now we use a while loop to compare the characters at these pointers. So while left is less than right, this is a condition until which the while loop will continue to execute. Once left pointer is equal to or greater than right, then we need to stop, because we are already in the middle of the string. So if the characters left and right don't match, then we should immediately return false. How to do that? We would take if char at left pointer is not equal to character add pointer, that is char add right pointer is not equal, then we should immediately return false. Else we should move to the next character. And how to do that? We would increment left pointer and decrement the right pointer. So if this while loop completes without returning false, then we know that integer is a palindrome. So we return true. Let me remove the extra space here. Let us run and check. Oh, there is a typo. It's accepted. Okay, now let me go over the time complexity and space complexity for this two-pointer approach. First up, time complexity. So the first operation is converting integer to string. It would take O of log to the base 10 n, where n is the value of the integer. This is because the number of digits in the integer is proportional to log to the base 10 n. Let me run an example to explain this. Suppose we have input number 1000. So log to the base 10, 1000 would give us approximately 3. So the logarithm base 10 correctly captures this information. The next operation here is like comparing characters with left and right pointers. So for this we need to traverse half of the string. So the time complexity should be n by 2, n being the length of the string. Since we have integer here, we can use the same approach, which is O of log to the base 10n by 2. So the overall time complexity would be O of log to the base 10n, since it would drop the constant and simplify that. The space complexity would be for the string conversion, since we are converting the integer to string. So for storing the string representation of the integer, it would require some space in memory, and it would be again O of log to the base 10n, as it would give us number of digits in the integer. For the string reversal, since we are not using any additional data structure, just left and right pointer, so there is no additional space for that. So the overall space complexity is O log to the base 10n. Let me take your input as 121. Now let us check the base case. 121 is positive and it doesn't end with 0, so we can proceed. Next is string conversion. So we would convert 121 to string, and now let me initialize pointers to left and right, left to 0 and right to the end of the string, which is 2. Now let us start the while loop. At iteration 1, left is 0 and right is 2. We first check the loop condition, which is left is less than right, and yes, it is. So we can proceed. Now we can check characters at left and right position, which is 1 and 1, and it matches. So we move to the next character by incrementing left pointer and decrementing right pointer. So left becomes 1 and right becomes 1. Now we again check the loop condition, which is left should be less than right, and it's not, it's equal, so it will return false, and the loop completes, and here we return true since all character comparison were successful. Now instead of using a two-pointer approach to check if the string is palindrome, we can reverse the string using StringBuilder class to reverse the string and then compare it with the original string. If yes, then we return true, else false. However, it's important to note that this alternative approach may impact the space complexity due to the additional storage required for the reverse string. Let me go over the code part first, and then we can go over the time and space complexity for this approach. I have commented the approach 1, which use 2 pointers. Now we will convert the original integer into string first. We can use integer.toString API as well, else we can use string.value of. Both are correct. Then we will reverse the string using StringBuilder class. Reverse API to convert it into toString. So now the reverse string is stored in the reverse variable here. We just need to compare it with the original string by using equals method. Let us run and check. Yes, it's returning. So now let us go over the time complexity and space complexity for approach 2. First up, time complexity. So for the first operation where we convert integer to string, the time complexity would be O log to the base 10n, where n is the value of the integer and log to the base 10n would give us number of digits in the integer. The second operation, which is string reversal. So reversing a string involves iterating through its characters, and the length of the string is proportional to the number of digits in the integer, which we get by using log to the base 10n. So the time complexity here is log to the base 10n, and the overall time complexity is O log to the base 10n. Little bit details on the StringBuilder's reverse API. So the StringBuilder class in Java has a reverse method that is used to reverse the characters of the StringBuilder in place. So when we say reversing in place, it means the characters are rearranged directly within the existing StringBuilder object without creating a new one. So the reverse method iterates through each character of the StringBuilder and rearranges them from end to start. The time it takes to perform this operation is proportional to the number of characters in the StringBuilder. Hence, the linear time complexity of O of n. So here, when we look at the integer, we can get number of digits, which is equal to number of characters in the string. Space complexity, however, is also log to the base 10n here, as string conversion will take log to the base 10n. for storing the string representation of the integer, and string reversal uh, would also require O of log to the base 10n, as we are storing the reverse string into a variable here. So basically both the two pointer approach and string builder approach have the same space complexity, which is log to the base 10n. However, in string builder approach, string builder explicitly store the reverse string, contributing to the overall space complexity of O of log to the base 10n. But in two pointer approach, it doesn't use additional space explicitly for storing the reverse string. So it performs a comparison in place in case of two pointer approach. So in summary, I can say both approaches have the same space complexity but differ in their handling of the reverse string. The two pointer approach is more memory efficient as it performs the comparison without the need of additional storage. Now we are done with approach 1 using two pointers. Approach 2 using string builder's inbuilt reverse API. Now let's talk about this third approach, where we do not convert the integer into string. Instead, we reverse the second half and compare with the first half. Okay, so the base condition remains the same. Let's jump over how we can reverse the second half of the integer and compare it with the first half. So I can do this by repeatedly dividing the number by 10 and adding the remainder to some variable called, say, reverse. Let me start that. Let me initialize variable reverse to 0. Now I will start here a while loop which will execute until the original x is greater than the reverse number. So inside the loop we would get the last digit of x using x modulo 10. Now we would update the reverse number by multiplying it by 10 and adding this last digit to it. Now we would remove the last digit from the original number x using x equal to x divided by 10, and we will continue this till the second half is reversed, and then we will compare the reverse second half with the first half of the integer. So for even numbers it would work, but for odd numbers we need to do one more check, which is x is equal reverse divided by 10. So for odd length numbers, the reverse second half has an extra digit. So we need to remove the last digit from the reverse second half before comparison. I will go over an example. to explain this. First, let us check if it runs. Okay. For example, now let us see this number 12321. This is an odd number as it has 5 digits. So when we start, x is equal to the original number and reverse is 0. At first iteration we will just check the while loop condition which says x is greater than reverse, which is true. We get the last digit which is 1 and add it to the reverse, which we do by multiplying reverse with 10 and then adding the last digit, which gives us 1. Then we update our x by removing the last digit because we have already added that to reverse. So it becomes 1232. So in second iteration again we check if x is greater than reverse. It is. So we proceed, we get the last digit and update reverse by multiplying it with 10 and adding that last digit, which becomes 12. 1 into 10 plus 2, the last digit which we have got. So it became 1 2. So we got this 1 2 and we update x to be 123 by removing last digit 2. So now reverse is 12 and x is 123. At the third iteration we check the while loop condition. 123 is greater than 12. Yes. So we get the last digit from x, which is 3, and add it to the reverse number by multiplying reverse by 10 and adding the last digit 3 here. It becomes 123. So and then we update x to 12 by dividing it by 10, which removes the last digit. So now x is 12 and reverse is 123. So during the fourth iteration, when we check the while loop condition, 12 is greater than 123, that is x is greater than the reverse. So the while loop condition check fails and it breaks the loop. So for odd length numbers, the reverse second half has an extra digit which is 3. So we need to remove this last digit from the reverse second half before the comparison. That's what we are doing. Reverse divided by 10, which removes this last digit, which becomes 12, and then we compare it with x and it returns true. For even length, the comparison is straightforward. Suppose we have this integer 1221. If the first half is 12 and the second half is also 12, it's a palindrome. Now let us go over the time complexity for this problem. So the time complexity would be O log to the base 10n, where n is the input integer. So we are dividing the input by 10 for every iteration. So that's why the time complexity is O log to the base 10n. The space complexity is O of 1, but since the reverse variable would store half of the digits from the input integer, we can say O of log to the base 10n by 2, but it's still relatively small compared to the input size, so we can say O of 1. Also, the algorithm here does not use any dynamic data structure like arrays or list. So the space uses primarily for integer variables. we can say O of 1 or O log to the base 10 n pi. As it stores half of the, as the reverse variable store half of the digits from the original integer. Okay, thank you.